Hello there, it's Alana Tuckey, and I've been asked to show you how to do this problem, which is 7.2, number 40 from the study plan. So let me click on the View an Example part here. All right, it says, as reported by a recent survey, the fast food restaurant with the best drive-through time had a mean time spent in the drive-through of 63.9 seconds. Assuming drive-through times are normally distributed with sigma equals 2.9 seconds, complete parts A through D below. Of course, mu is the mean, mu equals 63.9. Sigma is the population standard deviation, 2.9. So first of all, what is the probability that a randomly selected car will get through the drive-through in less than 60 seconds? Okay, so the best way to show this to you is with StatCrunch, believe it or not. It's much quicker and easier than the other methods. Well, not just quicker, but it also shows you the picture. All right, so the mean was 63.9. The standard deviation was 2.9. Let me double check those values before I go any further. 63.9, 2.9, that's right. Okay, and then I want to know the chances that it's less than 60 seconds. So that's your X value, 60 seconds. So I'm going to click right there, and there you have it. And if you wanted to put this in somewhere, you could press copy, right click, copy the image, and then go to your spot, right click, and, oh, not right click, go up here to paste special. And you want to pick device independent bitmap, and okay, and there it is. Now granted, I've already done this, it's a long story, but my first video had an error in it, so I'm coming back and redoing the whole thing. All right, so I get that the answer is 0.0893. All right, now what about Excel? Well, let's see here. So here I typed in the mean is this, standard deviation is 2.9, X value is 60. So to find the probability, I would take norm dist 0.0893, there we go. So the norm dist is 60, 63.9, 2.8 true. Or in my case, I just use cell references to get those values. And ta-da, there you have it. So there's the answer for the first part. This is part A. As a matter of fact, I'm going to label this the probability that X is less than 60. Now remember, the or equal to part doesn't really matter because this is a continuous distribution. So we just care less than, or equal to. It doesn't make any difference. They're all the same. All right, so there's that part for the first part. And honestly, I really only need this little bit right here. So let me go back here and delete all that. Again, sorry, this was my second take of this video. There we go. Beautiful. All right, now what about the calculator? All right, well, calculator, we can hit second distribution, hit normal CDF. Now the thing is, you need a lower edge and an upper edge of what you're shading. This is why I always like doing StatCrunch first, because you can kind of see a picture of it. So you want forever over here on the left, and you want to end at 60. So your right-hand edge is obviously 60, but your left-hand edge isn't 55. It's actually like forever that direction. It's negative infinity. Now a calculator can't handle negative infinity. So what it wants is negative 1 E, which is second comma. It's double E on the calculator, but it stands for exponent. It stands for exponentiation, actually. Which means times 10 to the power. It's scientific notation is what it is. So this is negative 1 with 99 zeros after it. It's a really, really small number. And then I want to stop at 60. That is my upper edge. My mean was 63.9. Standard deviation is 2.9. Paste. And enter. And there we go. Copy. Paste. And there you have it. All right, now what about part B? Well, first I'll prove to you that I'm right. Picture, picture, there it is, 0.089. Now what about the next one? I want to go to the right, so 70. So they want to say more than 70 seconds. Okay, well, again, let's start with StatCrunch. So it's going to be the standard one still. I'm going to switch this to a greater than. I want greater than 70. Compute. I like that better. All right, so compute, there it is. I'm going to copy and paste that in. It's tedious, but it's getting it done. Okay. That's beautiful. Lovely. All right, so now what about Excel? So I can see the answer, by the way. It's right there. It's 0.0177. What if you wanted to use Excel to come up with the same thing? Well, it's not too bad. So to use Excel, you'd find the left tail probability first. Let me copy and paste these over. Oops. Hold on one second. There we go. All right, so here's the thing. Excel always wants a left tail probability for that first value. So when you look at that first value here in that first position, oh, sorry, I'm doing it the wrong way. Never mind, I'm sorry. Losing my mind slowly but surely. Okay, it will always give you the left probability. Got it. So we're doing norm dist, which means it's going to be giving us the area to the left. In other words, it doesn't have this option. If you remember, when I did this with StatCrunch, I could choose left or right. But Excel doesn't have that option. Excel always does left, always. So that means that what I'm doing is I'm finding this giant left-hand area when I use norm dist. So I say norm dist, I want the mean, or excuse me, the x value, which was 70, comma the mean, which was 63.9, and the standard deviation, which was 2.9. And then I always want true for these values because I'm trying to add it up. I'm trying to accumulate that entire area, the red shaded area. I'm trying to accumulate all of that. So when I use Excel to do this, it's finding this big red area. And it's huge. It's 0.9823, which is what StatCrunch says it is as well. It's 9823. It's very large. So what I'm actually looking for is this little bit over here. But remember, the entire curve makes 100%, makes 1. So to find the right area, which is what I'm actually wanting, I take 1 minus that value that I just found. All right, so that's that part. I think that's cleaner than what I did the first time. So cool. Lovely. Now what about the calculator? Well, the calculator, clear. I'll go distribution, normal CDF, which is number 2, not number 1. It should say CDF up at the top. Now think about the area that you're shading. You want the left-hand edge, oops, wrong one. You want the left-hand edge of what you're shading, which was 70, right? And the right-hand edge is positive infinity. So what you're going to say is 70, enter, and positive infinity is positive 1, e, that exponentiation, scientific notation again. So it's really 1 times 10 to the 99. And then the mean, the standard deviation, all that's the same. So I'm just going to press enter, go down to paste, press enter, and press enter. And there you go. It's the same answer. All right. All right, now for the tough one, the between one. Now I want to show you this to you a couple ways. Now StatCrunch, the newest StatCrunch, has this lovely option of between. So if I click on it, it's kind of gray now. So I kept the mean and the standard deviation. I want my lower value to be 60. I want my higher value to be 70. Compute. And there you have it. So let me copy that in. All right. I'm going to show you something else in a minute, but I'm going to leave that there. There you go, so you can see. So the answer, we can see it right now, is 0.8929. Okay, so that's StatCrunch. And then let me do the calculator as well, because the calculator is also very, very simple. The hard one here is Excel, as usual. Once we hit Chapter 7 and on, I got to tell you, Excel is a pain. All right, so distribution, normal CDF, right? Again, I'm pressing 2 to make that happen. I want 60, enter, 70, enter, all this good stuff, enter, enter, enter. Oh, rats. I forgot to clear. I want to make this nice and clean. So go down here, press enter. There we go. Oops, didn't you see that? That's my iTunes. All right, let's see here. Boom. There's the calculator. Done, done, done. No troubles. I'm going to make this smaller. There's a reason I'm just doing this part in here. Oh, you know what? I forgot to show you that my last one was right here. Yep, see, it was 0.017, it's just like I said. And then I'm trying to do between 60 and 70. So this is what I'm trying to do here. Okay, so let me go back here. So we've seen StatCrunch and how simple it is. We saw the calculator and how simple that was. And now we're going to have to deal with Excel. Okay, so the way Excel works is that Excel only finds left tail areas. It can't do this between thing. It doesn't have the switch to allow you to switch from standard to between. It just does between, that's all. Or I'm so sorry, it just does standard. So StatCrunch is so much better for this stuff, and the calculator is so much better for this stuff. Now Excel, you're stuck. So what you do is you say, okay, look, you want between 60 and 70. So what Excel can do is Excel can find below 60, that's right here. And Excel can find below 70, that's right here. And then you can take the difference in the two, right? So you take the probability that X is less than 70, and you subtract away the probability that X is less than 60, and you'll have what you're actually looking for. So it's 0.982 something or other minus 0.089. Now, I'll grant you in this problem, I'm benefiting from the fact that I've already done it. So I've already found this part right here and this part right here. If I didn't find it already with Excel, I'd have to go find it. So it's really with Excel almost a three-step problem. You have to find this area, then you have to find this area, and then you have to subtract. With the calculator, it's one step and you're done. With StatCrunch, it's one step and you're done. And StatCrunch even gives you a picture of it at the same time. So you can tell how much I'm loving Excel at this point. But nevertheless, that's how you would do it. So let me put this in here. Okay. So that's how to do it with whichever technology makes you happy. Me personally, I would not use Excel for something like this. And like I said earlier in the video, pretty much from Chapter 7 on, Excel is not what you want. You either want StatCrunch or you want a TI-84 calculator. We basically will walk away from Excel once we hit Chapter 9 entirely. So you might as well start weaning yourself off of it now if it's something you like using. All right, I hope that video helps a lot with that. Oh, you know what, before I go, I think there's one more part, which is, are any of the probabilities unusual? Yep, unusual. Well, remember, unusual from Chapter 3 was defined as less than 5%. Now, we're going to fiddle with that once we hit Chapter 9 and 10 and so on. But for right now, you're still looking for less than 5%, which would be this one right here. So being greater than 70. So actually, if I want to clean this up, this is the probability that X is greater than 70. That's right here. And this one was the probability that X is less than 70, right? So this one right here is unusual. It's less than 5%. There you go.